Python is a dynamically typed language. That means values have types, but variables do not. Let's define a variable named x and a method to process it. Now reassign a new value to x and run the script again. As you can see, we reassigned x to a string and then called the method again, which fails at runtime. What's interesting is that specifying a type for a method argument, like num::int, doesn't actually enforce anything at runtime. The code still runs, even after reassigning x to a string. Why? Because Python's type annotations are optional and not enforced by the interpreter. However, you can check your code using tools like MyPy to catch these type issues before runtime. We'll come back to that later. Let's talk about duck typing. If it quacks like a duck, it's a duck. In Java, you'd define an interface like Quackable, and any class that claims to implement it must provide the quack method. Python, however, prioritizes behavior over the class type. Duck typing is very flexible, but errors can slip through at runtime, like in the case of our id generator. One way to make it safer is to use defensive duck typing using the hasater function. Now let's move on to something a bit more advanced. An ABC, or abstract base class, is similar to an abstract class in Java. Let's explore how it works using some examples. Here we're using duck typing again. At runtime everything works fine, but the type checker shows an error. Let's fix the type checker. We'll mark shape as an abstract base class and make circle its subclass. Michelangelo is a human being and a great artist, not a shape. Type checker positively verifies the circle, but not Michelangelo. It works as expected. Our artist could draw something that we do not desire or cause an error if he'd use a different method. Let's remove Michelangelo. He's a bit dangerous in this context. Let's focus on the draw method. If we change the type of the object it returns, the type checker may still be okay with it, but at runtime, it might fail. To make this safer, add type annotations to both the base class and the subclass methods. This helps the type checker catch inconsistencies. Once the type differences are detected, let's fix that code. Remember to annotate both methods. Enforcing method implementation. We can use the abstract method decorator to enforce that all subclasses must implement certain methods, like draw. Now the type checker and runtime are fine, and we'll use methods from superclass. Use abstract method annotation to enforce implementation. Now if a subclass doesn't implement draw, both the type checker and Python at runtime will raise an error. Let's uncomment the draw method. Now when the method is implemented, everything works fine. You can verify your classes using isSubclass and isInstance methods. Abstract classes allow for single inheritance, and while they're good to enforce more strict behavior, protocols are much more flexible. Let's walk through an example. We have a film player protocol and an MP4 class that matches the specified protocol. Now, passing the film player as a method argument allows the type checker to verify that the playFilm method received a proper variable. Let's define an MP3 class and pass MP3 instance to playFilm method. The type checker figures that MP3 has no video variable nor playVideo method. The failure may also occur when you run the code. You can define another audio player protocol and play music method that utilize it. It's possible to play music from MP4 because the film player protocol contains the audio, but you can't play the film using MP3. MyPy Type Checker will let you know about it. If you don't mark Film Player class as protocol, Type Checker will assume that MP4 film is an incorrect type, even if it matches the Film Player class. To sum up, Python is a dynamically typed language where the type of a variable can change at runtime. It prioritizes behavior over strict class types. That's why duck typing works. To make your typing safer, consider using abstract base classes or protocols. Tools like MyPy can catch type errors before you run the script, even if a code path isn't covered by tests. Type checkers are also commonly used in CLI pipelines. Feel free to play around with the code. It's available on my GitHub. If you found this helpful, give the video a like. See you in the next tutorial. Bye.